Good morning students, welcome to the class. In today's session we are just going to continue our discussion related to the complex number. In previous session we discussed the basics of the complex number, what is iota, what are the imaginary numbers, how can we calculate the modulus of a complex number, how can we calculate the conjugate of a complex number and the property related to the conjugate. Also we discussed the properties of the inverse of a complex number. Okay, in the previous session we have discussed that much kind of things, but in today's session we are just going to discuss that how can we calculate the argument of a complex number. Okay, we are just going to discuss these kind of things. Okay, so firstly we have discussed in the previous session that each complex number can be represented on the Cartesian plane, or you can say it complex plane, or you can say it Argand plane. Those numbers can be represented over there. Okay, so firstly, what is argument? At first we have to know this. So this is the real axis, we have discussed that, and this upper is the imaginary axis. Okay, these are two axes, and this will be plus, this will be plus, this is minus, and this is minus, and this is the origin. Understand that? Okay, we discuss these kind of things. Okay, so what is argument? Argument is nothing but it is the angle subtended with the positive axis. Okay, positive real axis. Understand that? We know very well that any number can be represented in any quadrant. Okay, based on the property nature of the real and the imaginary. Okay, if both are positive it will be in the first. So I'm saying this is a complex number and this is the angle theta. So this theta is the argument of that complex number, and it can be written as theta is equal to tan inverse b upon a. Okay, and we have to use the modulus over here. So this theta is the argument, okay, of complex number z. But you know what is going to happen over there in the examination? This is the direct formula to calculate the argument of any complex number. As we discussed that complex number will be represented in different kind of the quadrants based on the nature of the real and the imaginary numbers. Okay, if both are positive it will be first, if real is negative, imaginary positive, it will be second. In that way we have to identify. In the examination, the examiner is just gonna to provide the values of argument in the principal form. Okay, so in the options we are just gonna to get the principal argument in the options. Understand that? So we have to learn that how can we calculate direct principal value of the argument of any given complex number. Okay, firstly we should know that what is principal argument. Always remember that principal argument, if we are talking about principal argument of any complex number, it is always greater or equal to minus pi greater equal argument of z, and it will always be less than equal to pi. Understand that? So in the option it will be provided over here or over there. Understand? So argument never should be greater than 180 degree and never should be less than minus 180 degree. Now we have to learn that how can we calculate the principal argument just seeing the nature of the real part and the imaginary part of any number. Okay, so it is quite easy. So here is the quadrants, and this is the real axis, and upper one is the imaginary axis. Okay, this is the imaginary axis. This is 0 degree, this is pi by 2, this is pi. If we are just circulating like this, we are moving anti-clockwise. If we are moving we are moving in the direction of the clockwise, then it will be 0 degree. It is minus pi by 2 and it is minus pi. Okay, now always remember if you are in the first quadrant, so in that case theta means argument of z will be equal to tan inverse b upon a. If you are in the second quadrant, and as we discussed that the argument of any number should not be greater than the 180 degree in the positive direction. Okay, so we have to think the value should not be greater than the pi, then we need to subtract it from the pi. So in the second quadrant argument will be pi minus tan inverse b upon a. Now we are moving to third quadrant. So in the third quadrant principal argument will be minus pi plus tan inverse b upon a. Okay, this is in the third quadrant, and in the fourth it will be minus tan inverse b upon a. Okay, now always remember that. So these are the direct formulas that how can we calculate the principal argument of any given complex number. Okay, we can relate few more things from here. These points can be used in the examination just to save the time. Okay, what are the points? If anywhere you are just asked to calculate argument of z plus argument of z conjugate, okay, so always remember it will always be equal to 0. This will always be equal to 0. You can see over here, this is first quadrant, and we discussed in the previous session that if any complex number is represented in the first quadrant, its conjugate will be in the fourth. Okay, and if you are just gonna to add these two arguments, we are gonna to get 0. In the same way, we are gonna to add these two arguments, we are just gonna to get 0. So always remember, argument of z and argument of z conjugate is added, the resultant will be equal to 0. So this is quite simple. Okay, second result says that suppose you are asked to calculate argument of z1 multiply z2. There are two complex numbers, okay, multiplied with each other, okay, and they are represented, and you have to calculate argument of these two. So you can say that argument of z1 into z2 will be equal to argument of z1 plus argument of z2. So this is a quite simple result. Okay, these results of the argument are similar to the results of the logarithm. Okay, in the same way, if you are asked to calculate argument of z1 upon z2, so it will be equal to argument of z1 minus argument of z2. Okay, if anyway you see that you have to calculate argument of z to the power n, so it will become n into argument of z. Okay, so these are the quite basic simple kind of rules you have to keep in your mind just to do the questions, saving the time over there in the examination. Okay, in the same way, I'm gonna to tell you one more very important thing. Many times in your examination you are just gonna to see that there is the number, complex number, which is purely real and the positive. Sometimes you are just gonna to see that the complex number is purely imaginary and positive or maybe negative. Okay, then we don't need to apply these formulas. We can calculate applying the formulas. Okay, we can calculate the values, we can get the values just applying the formulas. But if we are just gonna to have few more things in our brain, it is gonna to save our time. Okay, so I'm just gonna to prepare a table over here, and it's this table is just gonna to be quite important for you. Okay, and it is just gonna to save your time. Okay, always remember the tricks, the short methods. Okay, you are just creating and learning those, they are gonna be very useful. Suppose a student is just writing a lot in the examination, it means he is wasting the time. Okay, so I'm just going to provide you very good kind of short tricks, short methods, and they are just going to be very useful for you. At first I'm thinking to provide you all kind of concepts, okay, the formulas, then we will start discussing the questions topic wise, firstly complex number, then another. Okay, so we will do those things. Okay, and I'm going to prepare a table over here, and the table says that I'm writing the z here. Okay, z means complex number, and over here I'm going to present the argument of z. Suppose a complex number is positive real. Okay, a complex number is positive and it is real. Now you tell me, these are the quadrants, on which line of the quadrant you are going to represent the positive real numbers. You can say that this is the origin and the positive real numbers will be represented on this particular line. If all the positive real numbers will be represented on this particular line, and you can see the angle over here, so argument of the positive real number will always be equal to 0 degree. Suppose, I mean to say, if a complex number is purely real and positive, then argument will be 0 always. In the same way, if it is negative real number, okay, negative real number, then argument can be pi or minus pi, because all the negative real numbers will be represented on this particular line. And here you can see that you can see that the argument is pi or minus pi. In the same way, if you are just going to get the complex number is purely imaginary, positive imaginary and purely imaginary, okay, positive imaginary, you can say that all the positive imaginary numbers will be represented here, and here you can see the angle, this is pi by 2. So if any complex number is purely imaginary and it is positive, then the argument will be pi by 2. In the same way, I'm just drawing here. In the same way, if a complex number is negative imaginary, negative and imaginary, okay, so negative imaginary will be represented at this line, and you can see the angle over here, so it will be minus pi by 2, okay. And when we will have the questions, we will see that these things are just gonna be very useful for us, okay. So so because of the shortage of the time, I am gonna to discuss only the things related to the argument today. In the next session, in the next video, we will discuss that how can we calculate the square root of any given complex number, and then we will discuss unity cube roots and few more things I have to discuss with you. Suppose there is a cubic equation in form of the complex number, how to calculate the root of that equation very quickly. Suppose there is a quadratic equation, okay, in form of complex number, how can we calculate the root of that quadratic equation very quickly. So all kind of things will be shared with you, okay. Thank you so much. Keep watching the videos and keep sharing, and if you like the content, please tell your friends to go through my channel, okay. Thank you so much.